Good evening. We are on the third day of our workshop Arduino for school students. In the previous sections, that is in the last week, Saturday and Sunday, we have seen about Arduino board, breadboard, LED, resistors, push button, digital this Arduino functions, digital write, digital read, then variable name, and at last we saw about if and else. And these are the things which we saw in the previous sessions, that is last Saturday and last Sunday. And we had an assignment or tutorial on that day. And 4 of them have submitted the assignment through mail. It is Sudish of 9th standard, Jeremy of 7th standard, and Jeremy has informed that he had done it in the hardware also and he got the answer. And Joel of 4th standard and Badresh SV of 4th standard. I congratulate them on behalf of Achievers Virtual University and FEMTech for their work and their response towards response. And in today's session, we are about to see about these sensors. In the last class, we used a switch to control an LED. And today, we will be using a sensor to control an LED. So what is meant by a sensor? It is nothing but a device that detects some actions and respond to it. And that response will be taken by our microcontroller to produce an output. Okay, so it is nothing but a device that detects and responds to some type of input from the physical environment. And mostly the response from the sensors will be of analog type, and this will be converted into physical type. Okay. And the sensor which we are going to see today is LDR, light dependent resistor. Light dependent resistor. And this light dependent resistor, it works on the principle of photoconductivity. No need to worry about this its characteristics, that is what are the properties on which it is working and such things. You just remember it works on the principle of photoconductivity, that's all. That is, on this surface, if light falls on this surface, the resistance of this device will go decreasing. If the resistance goes decreasing, it will conduct easily. So by using this principle, we are going to control an LED by using this device. And this is the circuit which we are about to implement today. See here, in the previous sections, we used the digital pins from 0 to 13. And today we will be using the analog pin from A0 to A5. Totally we have 6 pins from A0 to A5. Of this, we can use any one of the pins. As we have a sensor, it is enough to use any one of these pins. And this is the circuit that we are going to design, or we are going to draft today. This is the LDR, and this LDR is connected to the positive supply that is the plus 5-volt rail, and the output other terminal of the LDR will be connected to analog 0. We are connecting it to analog 0, and this is the pull down resistor which is connected to this ground, which is connected to the ground at one side and to the output side of the LDR. And there is no change in our output circuit. As we have discussed in the previous classes, it is connected to the 12th pin of our Arduino board through an current limiting resistor. Okay, so this is all about the circuit which we are about to design today. Now we can directly pass on to the simulation part by using Tinkercad. So the function which we are about to do today is analog read. Previously we discussed about analog write as well as not analog write, digital write as well as digital read. And today we will be seeing about this analog read. So now we can go on to our simulation part. So as in the previous sessions, we have gone into the Tinkercad. I have already logged into it. So create a new circuit. So our new page has started, and we can take our components as we require. First one is our breadboard. And our Arduino board next. We have got it. And next one is our LEDs. Okay. And resistor. We want two resistors. And next one is the LDR. So LDR is also known as photoresistor. That's all. So now we can start connecting our devices one by one. Initially, we can start from this ground. To avoid that overlapping, I am bringing this wire to this end. You can connect as per your convenience, but try to use the color codes. And next one is the red color. Okay. As I used a double click there, the wire has overlapped, so only I deleted it. Sometimes the collection will not be perfect in such cases. Okay. The color should color it to be red. Okay. And next one is to connect the LED through our resistor. We can rotate this resistor first. Okay. And connect it to the changes value. $330 ohms. And the next resistor, we should connect it to the terminal, that is the output terminal of our photoresistor or the LDR. Previously we connected the pin number 12 to the LED, the same thing. Today also we are connecting it to the pin number 12. Okay, through a resistor, that is our current limiting resistor. As in the previous case, we have used the orange color only, and this ground this LED. Yes, black. And the next thing is to ground this resistor. Okay, and this should also be in black. This is for our easy identification. If you are using color codes, you can identify it easily. And this is 10K. And the next thing is to connect a 5-volt supply to the photodiode. Okay, this is red. And one thing is remaining, that is we should read the value available on this LDR. So to read that, we should connect this to the analog pin A0 or any one of the analog pin. Yes, and let it give yellow color for this. Now our connections are all clear, and now it's time for our programming. Listen here, we have used an LDR. This LDR is connected to this plus 5-volt, and there is the terminal, the first terminal or the one of the terminal is connected to the plus 5-volt, and the other terminal is connected to the analog out. That is the analog pin of our Arduino. And we have done one thing. We have pulled down this terminal by using a pull down resistor. By using a pull down resistor. Now there is no change in this part, LED part. We have connected it to pin number 12 as we have done in the previous cases. So we have provided the ground also. We have provided the ground also. So let us now go for the coding part. Already we have some first codes here. So always select block and text. So there is nothing here now. There is nothing here now. We can start. So in our circuit, we have to read the output at the terminal of this LDR, and that should be given as input to A0. So for that, the command to be used is analog read. So let us go for that. The coding. So initially we should store it in some variable name. So as in the case of previous class, we can create a variable name, and here we can write this as sensor value. Sensor value. So this is the sensor value, and it is the first line. We are not setting the sensor value, that is, we have to read it from the input. So for that we are using analog read analog pin A0. So we took this read analog pin A0 from the input, that is the input blocks. See here, usually when we put these two things together, we got 4 lines. That is, integer sensor value is equal to 0. That is, we have done a declaration. Integer sensor value is equal to 0, and pin mode A0 as input pin. A0 means the analog pin. That analog pin is made to be an input pin. Next, once we read that value, now we can decide what to do with that value. So for that we can go for the control. Now the value will be available in sensor value, and as in the previous case, we can use the if else, and in that if else we have to do some mathematical comparison. So we are going for this mathematical block, and okay, and for comparison we are comparing the sensor value with some values. So first one is if sensor value is less than, let us give a value 500. What is this 500? This 500 is the analog value read by the sensor and given as input to the analog pin A0. Our LDR is reading some values, and that value will be dependent on the light or intensity of light which falls on that, and this value will range from 0 to 1023, 1023. Of this we set a threshold value, and that value is 500. Okay, and if this value, that is if the sensor value is less than 500, then our LED 12 LED which is connected to 12 should made high. So set LED pin 12 to high. If it is not, that is if the sensor value is greater than 500, then this LED pin should go low, that is the LED should be off. That's what we are going to plan. Low. So now you can go through the command codes. Initially, we have declared a sensor value. In the setup part, we have the two pins. A0 is the input pin and it accepts analog input, and pin number 12 is the output pin and it gives digital out. So sensor value is equal to, that is the variable sensor value is equal to analog read of A0, and after reading it, it compares it. If sensor value is less than 500, that is this value, the output of the sensor is dependent on the light intensity. If the light intensity is high, as we have connected it to the plus 5 volt, all the plus 5 volt will be available at the analog input. That is, and its equivalent value, it is, if it is plus 5 volt, its equivalent value will be 1023, 1023. And if it is connected to ground, its value will be 0. That's why. So if the sensor value is less than 500, then digital write, that is the pin number 12 should be become high. Else our digital write will go low. That's the thing. So we have done the coding and now we can check what happens with our circuit. I am going to start my simulation. Yes. And if you click here, this is dark condition. The left end is the dark condition and the right end is the bright condition. So I have made the program. If my slider goes to the right end, the LED will go off. That is, this is similar to that of an automatic light. If there is already sunlight or any other source of light, we are switching off the device which we are controlling. But if there is no light, that is, if in the dark condition, the light glows on. This is how I have made the program. You can have different combinations of this program. That is, this we can have different modes of programming. With the same circuit, we can program in different ways. I have used the analog value as it is. I have received the analog value from 0 to 1023, and based upon that value, I have fixed a threshold at 500, and based upon that threshold, I have decided whether to switch on or switch off my device. That's what happening here. That is, here when there is bright light from the external environment, my light, that is my device which I am controlling, goes off. And if I don't have any light, my device comes to on stage. So this is the condition. So next thing is to go for this coding in using our hardware. After demonstrating it on the hardware, again I will come to this circuit and show you something else different. Okay, so code. So I have to copy my code. Copied. So my antivirus is creating some problems. So I will do one thing. I will download with my Arduino IDE. It will be easy for me. File. So I have to take a new file. So today I am using, there is Arduino IDE. So this is the new file, and I have to file, save as. I will save it on my desktop itself. LDR. So next, this is the compiling. Video which I took yesterday while wiring this hardware. Once if I remove my hand fingers, the LED will glow. Okay. And now we can come back to our presentations. So we have discussed the analog read function, and this is the code which we have copied and pasted in our Arduino IDE. And here is the tutorial for today's class. That is the circuit which we have done. And this is the circuit which we have done today. And in this circuit, I have connected this LDR to the plus 5 volt supply, and I have written the code. You can rearrange the circuit, or you can reorganize the coding. Whatever you can do, you do, and bring a different circuit with different programming, or either you try for a different circuit or you try for a different programming. And in the programming, what I have used is analog read, that is sensor value less than 500. You should not use this code, that is sensor value less than 500. You should not use this condition. Other than this, you try to use some other conditions and bring out the code. And we can go back to our simulation and study one more thing, that is which is related to what we have done now. So I said that these values are analog values from 0 to 1023. When there is a 5 volt at the LDR, it will send 1023. When there is 0 volt, it will send 0 to the analog rate. So how to know this? We can read this by using serial monitor. Here this is the serial monitor. We can able to write this value to the serial monitor by this input block, that is an block present in the output, present in the not input, output. So that block is print to serial monitor, print to serial monitor, and you use this here, insert it here. And what should be printed in the serial monitor? That is, the sensor value should be printed on the serial monitor. So from variables, you take this sensor value. Instead of hello world, put this sensor value here. Sensor value with new line. So now you can see two new things in our code. That is serial begin of 9600. This is a command to start the serial monitor, and 9600 is the baud rate. No need to worry about that. Just remember, that is when we are coding for a serial monitor, we should give in the setup, we should give serial dot begin of 9600. That is the baud rate may change. Here we are using 9600, which is the default baud rate. And here we will be using the serial dot print line, or here we are using the new line, isn't it? So it comes like this. Here print serial sensor value, serial monitor sensor value with new line. So here comes serial, that is serial print ln sensor value. So these are the two new lines inserted by this block. Now we can go for this simulation. Before going to that simulation, let us run this. Yes, it is running, and now click the serial monitor here. You can see the values. You can see the values. Now how to change the value? We have to change the slider. Go to the slider, change these values, and again come to our code and see the serial monitor here. Now it's 929. So again go to our code, not code, to this and bring it to the end. 974. Here the maximum value is 974. So again we can go for the minimum value. Slider is made to its minimum value. See here it's 54, not 0, here 54. So we have set at a value 500. So in real time also you can use this serial monitor. In serial monitor, if I write the code here, I can copy this code with serial monitor, copied. I go to my Arduino IDE and change the whole program, paste. So now I am writing with this serial, compiling. Done compiling, I have to download it. Done uploading, and you click here. This is the serial monitor icon. See here, that is, it comes with the time. So if I touch here, the value changes. See here. Once I touch my sensor, the value changes. So it is so fast, we can adjust the delay to adjust the speed. Okay, as we have not introduced any delay, it comes so fast. Here. Okay. I think with this we can so once again, so we have discussed Arduino board, breadboard, LED, resistor, push button, digital write, digital read, variable name, if else, and today we have discussed analog read, and serial monitor, that is serial begin of 9600, as well as serial print ln. Two more commands. And once again I congratulate the participants who sent the answers. That is Sudish of 9th standard, Jeremy of 7th standard, and Joel of 4th standard, and Badresh of 4th standard. So, and today's tutorial is, you should find some other ways of converting this into a new circuit. That is new code. You should try to change that. that is the sensor value less than 500 by some other words or some other codes. You have the option of changing the hardware as well as option of changing the program. You try any one method and bring a new code. Okay, so herewith we conclude today's session. Thank you for the participants and their parents who made encourage them to participate in this workshop. Okay, with the expectation that we can meet in the next class, we can stop the today's session here. Thank you.